Now that we know how to create a UDT or a user-defined type, now we need to have a look at instantiating one or creating an instance of that type. Remember that UDTs on their own don't do anything. You can't sort of write variables to them or values to them or anything like that. They need to be instantiated in order to actually make use of them. So there are a few different ways that we can do this. I'll show you the way that I like to do it first and explain why I do it this way, and then I'll show you a different way after. But typically, a UDT will be created and it will typically be used as part of a data block in some instance. So in some place, we will have a global data block that has a UDT instance within it. There are some very small cases where you only use UDTs for interfacing, but those are quite limited. Usually we'd end up with a data block and a UDT. So I'm going to call this one UDT1 example and go ahead and create that. And this is just a bog standard global data block. We can fill this in with anything that we want. I'm going to go ahead and put in typed, and in here in the data type I'm going to put UDT, and I'm going to create a quarter turn valve. Now what you'd actually do is name this, instead of UDT1 example, this would be named your valve. So this might be quarter turn valve 1, for example. And what we now have is our quarter turn valve 1 with everything. Let me just expand everything. With everything that we created in our UDT within it. And it's ready to use, and it's all accessible on this typed. And we'll come back to why I'm using the variable name typed in a data block when we cover bespoke values later on. But for now, we use typed because it's connected to a typed or a data type. And when we start doing library management as well, they get called types in library management. It all ties in nicely that you can reference a asset by its name, put dot types, and you know that everything that you are working with is the defined data from a UDT for that particular asset. It also means that when you come to do things like dynamic things on SCADA or HMIs where you're using scripts and things like that, you recognize that you're always working with the asset and then the typed data set. And it just means that there's no ambiguous naming or differences between different types of assets. Everything is accessed on this typed variable. For good practice, I would put in the comments what this valve actually is. So this means that when we come to use this data and we put dot typed, you get the comment that says, you know, it's QTV_01 as the asset name. The comment for that typed data is the description of the valve or the asset that we're working with. And you can go ahead then, once you've created one of these, you can go ahead and just copy and paste and you'll create the next one. Very frustrating that Tier Portal removes the leading 0 because if you've got lots of these, typically I would put a leading 0 for anything under 10. But you can then open this one. Everything is ready. It's a brand new instance of your UDT data. All you need to do is change the comments to a new comment and you have your next asset done. So one of the things that I would sort of try and think about is, it's very tempting if you've got a lot of assets to say, well, I'll just have one data block and that one data block can have all of the asset types in. And yes, there is an argument for that. So we could have one data block that's got QTV02 and QTV01 in it, and then so their names would be where this typed field is. In fact, let's just go ahead and show you what I mean. It'd be a bit easier if I was to demonstrate it. So you could go ahead and do QTV 01 UDT quarter turn valve, and you could do QTV 02. And whilst there is nothing inherently wrong with this, if you have lots of assets in here, and then as time goes on, your data types are updated and they become longer or shorter, what happens is you're changing a lot in the block then, because every single instance, every single length of this changes every time you change the UDT. And it means that things like SCADA, HMIs, whilst a lot of things are symbolically referenced and it shouldn't affect it, depending on how you've got your project set up, you might find that you then need to go and pass all of your tags back to your HMI or SCADA, readdress them where they're pointing, because the actual memory offset is different. That's not that bad. If you start mixing data types in here, then you start running into lots of issues, because if you have different data types in here, so if I was to change this one to a UDT analog instrument, and we call this analog instrument 1. Now, if I was to go and update the UDT for the analog instrument, its length would change. That means that this block's length would change. That means that this block needs to reinitialize. And if this block is reinitializing, then you're losing data, or you're setting data in the quarter turn valve back to start values when it actually has nothing to do with the update. Whereas if you follow this split approach, if we had two analog instruments in here, AI underscore 01 and AI underscore 02, if we then went and changed the quarter turn valves, the only blocks that would need to update would be the quarter turn valves, and it preserves all the information in your other assets. So but personally, I prefer to do it that way. If you're doing it that way, then you're protecting your data. If you go down the road of putting stuff together, you need to understand that if you make changes to any asset that appears in that data block, you're going to affect the data for other assets. And I know that we can activate memory reserve in optimized data to sort of preserve that and help, but you have a limit on that. And if you've got lots of things in here that are all wanting to change, then you'll find that you'll eat up that memory reserve quite quickly, and it might not save you anyway. So it's better to have multiple blocks, multiple instances of your UDT, than have them all bundled together. That's my experience anyway. I think for tiny projects or small projects where you only have a handful of assets, you could probably get away with it, but I think it's good practice not to. I think it's good practice to split this stuff out. So with that being said, hopefully that gives you an idea of sort of how to set stuff up in the project tree, how to lay your stuff out. I mean, this what we're looking at right now is not right, but this sort of approach here should make sense, and it will make sense more when we come to use it with function blocks in the later sections. But for now, if you're setting up data, you've set up your UDTs, and now you want to instantiate them and create an asset data block, this is the best way to do it, and this is the way that the rest of the course will be done. But before we move on, there is another way, and I don't do it this way because I want the flexibility of being able to add stuff that is different for each asset while still having the common data. And like I said, we will come on to that in the next lesson where we're managing bespoke data requirements. But you can also pick a UDT from this list. So we could pick UDT quarter turn valve and call this one QTV03. And what you find is, if I just split the screen, so O2 has typed and then the variables inside, or the structure inside, whereas QTV03 has the structure in the actual data block, and you're unable to change anything, you're unable to add anything, because it's obviously part of the UDT. And it's worth noting that the only way you can find out what UDT is being used is if you go to properties and then go to general. It says data block derived from UDT quarter turn valve. That's how you can tell what type this data block is actually using. If we were to do the same for QTV02 and look at general, you'll see that this one's a standard global data block. So the differences between these are purely flexibility. The flexibility approach in being able to pass a variable as opposed to an entire data block, being able to come underneath here and say add row and type a specific variable in that would only affect QTV02. If I add something in here, just let's not do another entire structure, but just a Boolean, for example, that hasn't affected QTV01 at all. QTV01 doesn't have that variable, but the second valve, valve 2, does have that variable. And you don't get that flexibility if you go down this approach. You'd have to create a separate data block for bespoke data for that asset. And there's also some drawbacks with older HMIs that won't accept data blocks directly, where you wouldn't be able to reference QTV03 as an entire variable because the HMI recognizes it as a data block. And it's like you can't pass an entire data block to a faceplate or to an object. So you would have to go down this route of having a typed value. So I appreciate there was quite a lot of information to take in there, and it came quite fast. But the more we go through this and the more we see these pieces come together, the more you'll realize why it's done this way and sort of how it's managed. In the next lesson, we will have a look at managing one-off data requirements and what those sort of requirements might be.